Today, we embark on an exciting journey to explore the nature of time and whether it is truly real or just an illusion. In our daily lives, we constantly feel the passage of time. We wake up to the sound of an alarm clock, check the time to go to work or school, and cherish every moment. But does time really exist? Or is it all just an illusion? As Albert Einstein once said, "Time is an illusion." This profound statement challenges our conventional understanding of time and invites us to delve deeper into its true nature. Is time a fundamental aspect of reality, or is it something our minds have constructed to make sense of the world around us? To answer this question, we will look at what great minds throughout history have thought, what scientific theories say, and what recent research reveals. If you're ready, let's dive into the depths of time and uncover the truths behind this fascinating concept together. So what is time? How do we define it? According to the dictionary, time is the continuous sequence of events from the past to the future. But is this definition really sufficient? In our daily lives, we use clocks, calendars, and dates to measure time. We set alarms to wake up in the morning, schedule appointments according to specific times, and plan our holidays by looking at the calendar. All these tools show us the flow of time, but can they fully explain what time actually is? Time is a concept everyone thinks they understand, but when deeply questioned, it becomes challenging to grasp. For instance, is time measured in seconds and minutes the same everywhere in the universe? Are concepts like past, present, and future as fixed as we think? These questions require us to understand time more deeply. Today, we will pursue these complex yet fascinating questions. Understanding the definition of time will give us a broader perspective on its nature. Now let's go back in time a bit and see what great thinkers throughout history have said about time. We've understood the definition of time. Now let's delve into the thoughts of great philosophers from history. Ancient Greek philosophers deeply pondered the nature of time. For example, Plato viewed time as a moving image of eternity, born with the universe. He saw time as an unchanging and infinite reality. Aristotle, on the other hand, defined time as the number of movements in respect to before and after. According to him, time is a measure of change, and without moving objects, the existence of time is unimaginable. These thoughts have been discussed and developed for thousands of years. However, the question of whether time is an illusion is more complex. In modern times, some philosophers argue that time exists only in human consciousness and is not a real entity. According to this view, time is merely a tool we use to sequence and understand events. Especially philosophers like Julian Barbour have popularized the idea that time does not exist. Barbour argues that time is an illusion, and only now moments exist. According to him, past and future are concepts that exist only in our minds. These philosophical approaches show us how complex and profound the concept of time is. The question of whether time truly exists or is just an illusion remains a major mystery. Now, let's look at Newton's understanding of time and see how time is viewed from a classical physics perspective. We've understood philosophical approaches. Now let's move on to one of the great names of classical physics, Isaac Newton, and his understanding of time. Newton laid the foundations of modern science with his theories in the 17th century. His concept of time still influences many fields today. Newton viewed time as absolute and universal. According to him, time flowed the same for everyone, and everything in the universe moved within this absolute time. In Newton's definition, time was an independent entity. Nothing could affect it, and it continued to exist on its own. Newton's view of time was widely accepted in the scientific community for a long time. His concept of absolute time formed the basis of classical mechanics. According to this understanding, all events in the universe occur in a specific order, governed by absolute time. However, this concept of absolute time later led to significant debates in the scientific community. Especially in the early 20th century, Albert Einstein's theory of relativity radically changed the Newtonian understanding of time. Newton's concept of time helped us understand how classical physics works, But as science progressed, our understanding of the nature of time deepened and changed. Now let's move on to Einstein's theory of relativity and explore the relative nature of time. We've understood Newton's concept of time. Now let's move on to the early 20th century and Albert Einstein's revolutionary theory of relativity. Einstein radically changed our understanding of space and time with his theories. Einstein's special theory of relativity showed that time is not absolute, but relative. According to this theory, time can flow at different rates depending on the observer's motion. For example, time moves slower for someone traveling at speeds close to the speed of light. This finding completely overturned the idea of time being absolute and universal. Later, Einstein developed the general theory of relativity. This theory demonstrated that gravity affects the flow of time. Large masses bend the space-time around them, causing time to slow down. For example, near a black hole, time moves much slower compared to time on Earth. Einstein's theories created a revolution in our understanding of the nature of time. We now know that time is not an absolute concept, and that its flow can be affected by factors such as the observer's state and gravity. These theories have led to many important discoveries in modern physics and cosmology. The theory of relativity shows us how flexible and complex the concept of time is. Now let's move on to the role of time at the quantum level and see how time is addressed in quantum physics. Einstein's theories of relativity showed that time is relative. But to understand the nature of time even more deeply, we need to delve into quantum physics. Quantum physics examines the laws that govern the subatomic world, and here, time is considered in a much more complex way. In quantum mechanics, the role of time is quite different from that in classical physics. In the quantum world, the behavior of particles is described not by certainty, but by probabilities. How these probabilities change over time is explained by equations like the Schrödinger equation. However, these equations struggle to determine the direction of time. Another interesting phenomenon is quantum entanglement. When two particles become entangled, they can instantly affect each other's states regardless of the distance between them. This situation forces us to rethink concepts of time and space. Entanglement shows that time does not flow in a linear and continuous manner in the classical sense. In quantum physics, there are still many unknowns about the nature of time. For example, theories of quantum gravity, which attempt to unify quantum mechanics and general relativity, propose new and radical ideas about the nature of time. One of these theories suggests that time is not a fundamental component, but emerges only under certain conditions. Quantum physics constantly questions and expands our understanding of the nature of time. The role of time in this microscopic world provides us with new insights into understanding the most fundamental building blocks of the universe. Now, let's move on to the debates about whether time is an illusion and see what views exist on this topic. We've explored the physical and philosophical foundations of time. But perhaps the most perplexing question is whether time is an illusion. This debate is addressed from both philosophical and scientific perspectives. Some philosophers and scientists argue that time exists only in human perception and is not a real entity. According to this view, time is merely a concept created by our minds to sequence and organize events. This idea was especially popularized in the 20th century by philosopher Julian Barbour. Barbour argues that time does not actually exist and that only now moments are real. According to him, all moments in the universe exist simultaneously, like an infinite photo album, and we experience only one of these moments. This approach completely reverses the classical understanding of time. Barbour's theory is compatible with Einstein's theory of relativity, emphasizing the relative and flexible nature of time. However, there are those who oppose this theory. Scientists who argue against the idea of time being an illusion believe that time is an integral part of physical processes in the universe. For example, entropy and the laws of thermodynamics show that time is a one-way progressing process. The debates about whether time is an illusion stand at the intersection of science and philosophy. These debates prompt us to think more deeply about the nature of time and reevaluate our place in the universe. Now, Let's examine the role of time in human perception and the concept of psychological time. How does the human brain perceive time, and how does this perception differ among individuals? Let's explore these fascinating questions. After understanding the philosophical and scientific approaches, let's now delve into the role of time in human perception. Psychological time deals with how time is experienced and perceived individually. This concept focuses on how people feel the flow of time. We have all felt that time sometimes flies by and sometimes stands still. Time seems to fly during enjoyable activities, while a boring meeting can make minutes feel like hours. This difference in perception is related to how our brain processes time. Our brains use certain neurological processes to sequence and organize events. Internal clock mechanisms in the brain help us measure time. However, these mechanisms are not always perfect, and emotional states, levels of attention, and environmental factors can influence our perception of time. For example, in stressful or exciting moments, time may seem to slow down. This occurs because our brains try to process more information in such situations. Similarly, during routine and familiar activities, time can seem to fly by because our brains require less information processing. Time perception also varies significantly among individuals. Factors such as age, cultural background, personality traits, and life experiences affect time perception. For example, a summer vacation may feel endless for a child, while the same period can pass in the blink of an eye for an adult. Psychological time shows that time is not just a physical measurement, but also a subjective experience. This highlights once again how complex and multifaceted the concept of time is. Now, let's move on to the concept of cosmological time and examine how time has flowed since the birth of the universe. Let's trace the cosmic time from the Big Bang to the present day. After understanding time in human perception, let's now look at how time operates on cosmic scales. Cosmological time examines the process that has occurred since the birth of the universe and how this process has shaped events in the universe. The beginning of the universe, approximately 13.8 billion years ago, was marked by the Big Bang. This colossal event was the birth of space-time itself. Immediately after the Big Bang, the universe entered an incredibly rapid expansion phase known as cosmic inflation. This process created the structure of the universe we see today. Following the Big Bang, the universe was filled with a hot, dense plasma of energy. At this stage, time as we know it had not yet fully formed. As the universe cooled, particles combined to form atoms, and the first light filled the universe. This light is known today as the cosmic microwave background radiation. Over billions of years, galaxies, stars, and planets formed through processes governed by gravitational forces. The structure of the universe was shaped, and large cosmic structures emerged. During this process, the flow of time and the sequence of events changed as the universe expanded and cooled. The scale of cosmological time is very different from that of human life. The lifespan of a star can last billions of years, while the formation and evolution of a galaxy take much longer. Understanding these large-scale time frames helps us grasp the history and future of the universe. Today, modern astronomy and cosmology use advanced telescopes and space observatories to study the evolution of the universe over time. These observations provide us with a better understanding of the events and processes in the depths of cosmic time. Now, let's examine the place of time in science fiction works and how it is depicted in these works. Let's look at popular topics such as time travel and parallel universes, and see how science fiction has contributed to our understanding of time. We delved into the depths of cosmological time and examined the history of the universe. Now let's explore the place of time in popular culture and how it is depicted in science fiction works. Time travel, parallel universes, and more frequently appear in science fiction works, providing new perspectives on time. Science fiction often uses the concept of time travel. These works depict themes such as traveling to the past or future, changing the course of events, and living in different time periods. H.G. Wells's novel The Time Machine is one of the earliest and most influential examples of this genre. Wells imagined that time did not flow like a river, but was something that could be manipulated by humans. The theme of time travel also appears in many films and series. The Back to the Future series is a popular example of this. In the film, the idea of traveling to the past and future with a time machine and changing the course of events is explored. These types of stories make us think about the flow of time and the interconnectedness of events. Parallel universes and multiverse theories are also frequently depicted in science fiction works. These works tell stories set in different time periods or alternate realities. Series like Fringe and Rick and Morty explore the different time flows and events in parallel universes. These types of stories suggest that time does not flow linearly and continuously, and that alternative realities can produce different outcomes. Science fiction addresses many topics we think about regarding time in an entertaining and thought-provoking way. This genre introduces new ideas and theories about the nature and functioning of time. It also expands our imagination about how time can be manipulated and what the consequences of such manipulations might be. Now, let's move on to the scientific research on time and explore the latest theories. What are the most recent scientific studies on time, and what new theories have been proposed? Let's find answers to these questions together. After exploring the fascinating world of time in science fiction works, let's now look at the latest research and new theories scientists have proposed about time. The scientific community continues to make new discoveries about the nature and functioning of time every day. Modern physics is constantly working to develop a deeper understanding of the nature of time. The inconsistency between quantum physics and the theory of general relativity has led to the proposal of new theories about the nature of time. Scientists are trying to understand the fundamental nature of space and time by combining these two theories. Another important area of research involves structures known as time crystals. Time crystals are theoretically structures that move perpetually in an endless loop without consuming energy. The discovery of these structures could provide revolutionary insights into the functioning of time and energy. In the field of cosmology, the expansion of the universe following the Big Bang and its effects on time are also of great interest. Studies continue to investigate whether the expansion rate of the universe changes over time, and what these changes tell us about the universe's future. These studies can help us understand how time operates on a universal scale. Additionally, research on the nature of time is not limited to physics. Neuroscience and psychology also conduct many studies on how the human brain perceives time and how this perception differs among individuals. These studies contribute to our understanding of the neurological foundations of time perception and how this perception can be altered. Finally, some theoretical physicists are developing radical theories suggesting that time does not actually exist and is only an emergent property. These theories offer new perspectives on understanding the fundamental building blocks of the universe and raise deep questions about the nature of time. Recent research and new theories continue to reveal the complexity and depth of time. As scientists strive to fully solve the nature of time, we continue to follow these fascinating discoveries. Now, let's move on to the final section of our video and summarize our findings about the nature of time, discussing what we can learn about this topic in the future. We've reached the final section, dear viewers. Today we took a deep dive into the nature of time and whether it is an illusion. We discussed scientific and philosophical approaches, human perception, cosmic time, and how time is depicted in science fiction works. So, in light of all this information, does time really exist? Or is it just an illusion? Is there a definitive answer to this question? Let's think together. Physically, time is shaped by the sequence of events in the universe and the influence of forces like gravity. Quantum physics, the theory of relativity, and cosmological observations reveal the complexity and flexibility of time. From a philosophical perspective, time may only be a concept created by the human mind. Psychologically, our perception of time is shaped by our emotions, attention levels, and surroundings. Among all these different and complex perspectives, it is difficult to reach a definitive conclusion about the nature of time. However, one thing is certain: Time plays a central role in the functioning of the universe and our lives. Here, we want to leave our viewers with a question. Do you think time really exists, or is it just an illusion? Share your thoughts and theories with us in the comments. We are curious about your opinions on this topic. And remember, as scientific discoveries continue, we will learn more about time. Who knows, maybe one day we will fully understand the true nature of time. As we conclude our video, we invite you to think deeply about this intriguing and complex topic. We will continue to advance in the light of science and philosophy to uncover the true nature of time. Thank you for watching. See you in our next videos. Goodbye.